Hey there, I'm Renato, and today I'm going to talk about Vanilla RAG with LangChain and Chroma. So I've seen loads of these diagrams on my LinkedIn feed or some other feed, and but not often you see the actual code. So I decided to put together a very simple Jupyter notebook so most people can actually see how the code would look like. And I'm also putting together a production ready version of this. So if you're interested, let me know in the comments. Let's get started. So we're going to load the data, we're going to split, then embed using OpenAI, store that in Chroma vector database, retrieve, and finally evaluate. I'll probably do this in two different videos, so bear with me. Let's get started. So loading, we're gonna extract, gonna find some document, some file that we want to use it. And in this case, LangChain offers a method, a class CSV loader that you can pass your file path and it will load it for you. In this case, I'm investigating a little bit more in terms of page content, the title, authors, and different columns you might find in that CSV. But the rest of the video, I'm going to talk about PDFs, and LangChain also offers that, like the same class, but to work with PDFs. And here we can see that in terms of page content, I extracted the 100 first characters. Here they are. And then some metadata as well. And you can also check here all the details. That's pretty cool. But then once all that has been loaded, I need, before passing that into a vector database, I need to split into different chunks. And that part is really important, because that's where it's going to be converted. It's going to be embedded into vectors. So we have two key parameters here that we want to talk about. The first is chunk size. So how large each of these chunks will be in terms of characters or tokens. There are different ways you can work around that. But the more chunks you have, you might need more comparisons in terms of similarity, and the more comparisons you have, the lower the query latency. So keep that in mind. In terms of chunk overlap, is how much from the previous chunk is also going to be used in the following chunk, so you don't lose context. That's pretty important, especially when it comes to text that it follows a very specific logic. And in the case of research paper that I'm using right here, that's definitely something I want to work with. And in this case, starting very conservatively with 1,000 characters and a 20% overlap. Also, focusing like on LangChain text splitters, they have a recursive character text splitter. And let me just run this. You can see here that I've used separators. These are 2 lines. Then if this is not happening, then it will look for 1 line and then for a space between words. So every time it goes back, it tries to find a word that still makes sense, and it will break whenever it finds one of these. If not the first, then the second, and then the third. That's why you'll see that chunks will have, roughly will have different sizes. But in this case, we have like 92 chunks. So let's have a quick look on, let's inspect these chunks. So in this case, we're looking for a little bit more detail, and it's on page 8. There's 963 characters. You notice that I asked for 1,000, but because of the way that it was split, this specific chunk had 963. And here's a preview talking a little bit about the text, like general purpose architectures for NLP and so on and so forth. So hope this beginning has helped, and I will do a follow-up video on this where we can start talking about embedding. All right, take care, and see you in the next video. Thanks.